What up, folks? How's it going? This is Abhijit here, and welcome to Devops Challenge Hub. So let's have a look at today's interview question. So today's interview question is, what is Kubernetes operators and why do we need them? And give some example. So as usual, I will explain you the concept. Then we'll see it working. I will give you a demo so that concept is clear. And after that, we'll have quiz at the end. So stay till the end and participate in the quiz. And so let's start. So let's say, like you have went to your friend's house and your friend asks you to switch on the laptop. So you know how to switch on it because you will just press the power button. But if your friend says that, okay, now you take backup of my important files, you don't know what are those important files, how to take backup, what kind of application he is using to take backup, right? Where to take backup, whether it's a Google Drive or Dropbox, where he wants to take backup. You don't know how to log into the laptop also, but you know how to switch on the laptop. So similarly with Kubernetes also, Kubernetes knows how to switch on the container, how to start the container, how to kill the container, right? But it doesn't know application specific behavior. Okay. So in Kubernetes terms, Kubernetes knows how to start and stop app, just like you can turn the laptop on, but it doesn't know the internals of the complex app, how to install, upgrade, backup, recover from crash, and scale it. So operator is like a trained assistant, which will help you to do that. So operator will tell Kubernetes how to do this, how to configure it, how to set it up. So operator will be doing all this job, right? So it's an assistant for the Kubernetes, and that's how you expand the intelligence of the Kubernetes to handle special apps. Okay, so how does it do that? It does using CRD, Resource Definition. CRD, Custom Resource Definition, to teach Kubernetes about this app. Kubernetes may not know about this PostgreSQL. So it will tell what is this. It knows about pod, it knows about other things, but it doesn't know about this. So it tells about this custom resource. So it has custom resource definition. It also has a controller to keep checking the app status and take corrective actions. So I hope it's clear why we need operators and now how it helps. So operator is what is an operator? Let's say you are running complex application like PostgreSQL database on Kubernetes. Normally, you need to do a lot of work like install it, configure it, back it up, recover if it crashes, scale it if needed. So operator is like a assistant that does all the work for you. It understands how the application works, monitor it constantly, automatically takes action when something goes wrong, handles upgrades, backup, configuration changes. Like for example, your friend's laptop some configuration changes. If for us to do, you won't be able to do it, or some backup, right? So similarly, here also, uh, operator will be able to handle all this because Kubernetes uh, doesn't know how to do this. So Kubernetes operator is like a robot assistant for your app, trained on specific thing. Like there will be operator for PostgreSQL, or there will be separate operator for Kafka. Or if you have written an application which is your, like you have developed, you only know about it. So you will have operator for that. You will be creating a operator for that, right? And it reacts smartly when things changes, makes complex app easy to manage. So Kubernetes knows how to run containers. Operator knows how to run applications. So what is CRD? We know that operator use CRD and controller. So what is CRD? CRD is custom resource definition. So Kubernetes knows object like pods, service, a way to expose that. It knows about deployment. But sometimes you need to define your own types of resources. That's where CRD comes in. Okay, we'll see that in example. Think like CRD that if you say that hello Kubernetes, I want to understand something called PostgreSQL cluster. So then you have to create a resource PostgreSQL cluster in Kubernetes, just like you create a pod or service. Then Kubernetes will understand. Once you install that, for example, you want to run PostgreSQL, and once you install that CRD, then you will be able to write a YML file like this, where you will specify kind PostgreSQL. Otherwise, Kubernetes won't understand what is this. It won't be able to understand what is this PostgreSQL because it doesn't have any knowledge about this. It knows about pod, it knows about uh, replica set, etc., like deployment, but it doesn't know about this. So once you install this CRD, by CRD, it will know that what is this. And by writing this simple YML file, operator will help you to create two database pods, handle failover, enable backups, and support upgrades. Okay. So operator work with CRD, like operator, how do operator work with CRD? The CRD defines the structure of the resource. For example, here PostgreSQL. Then operator watches for changes to those resource. And when you create or upgrade PostgreSQL resource, operator takes action, create, delete, pods, changes, settings, etc. And controller is a Kubernetes concept that continuously watches the difference between desired state and actual state and tries to fix the difference. So, uh, operator also has their own set of controller which will monitoring those specific apps which are created or handled by CRDs. So, operators are controllers plus CRDs. CRD defines new object type and controller watches and act on it. So, let's start with the demo. So I have already created a cluster. I have installed a kind cluster on my Mac laptop. So I did do install kind. And then after that, I have done kind create cluster minus minus name operator demo. Kind create cluster minus minus name operator demo. So cluster is already created. Now I will install operator for PostgreSQL operator created by Zolando. So let's create a namespace and then apply that. Okay, and then we'll install that operator. So this, what it will do, this is created by Zalando, and it installs CRD for PostgreSQL. It starts the controller operator, and operator watches any PostgreSQL cluster objects you create. Okay. So operator is created. So what it did, it created config map PostgreSQL operator created, service PostgreSQL operator created, deployment apps PostgreSQL operator created. All these things it did that. Okay. And then once it is done, now I will be able to create a PostgreSQL cluster. So I have already created a YML file. Now Kubernetes will understand. Kubernetes will understand this kind because I have installed this operator. So operator has installed CRD and controller. So now because of the CRD, it will be able to understand this kind PostgreSQL. And what I'm doing that I'm creating a demo DB and two copies I'll be creating. Version will be 14. Okay. So let's do that. Apply this one. Kubernetes apply. So using kubectl, I'm talking to Kubernetes. Kubectl apply minus F Postgres cluster YML. So it has created. And now what happens? CRD defines PostgreSQL object. So this object will be defined by CRD because Kubernetes doesn't know. Now it's able to understand because CRD can define this for Kubernetes. Operator says new SQL cluster is requested, so it will start to PostgreSQL pods, create a database demo, and set up the users. All these things it will do. Now I will see what are the pods are there. Pods are running. kubectl get pods. kubectl get pods. Yeah. So you can see demo DB0 is running. Demo DB1 will also getting created. Will be created. It will taking time. And Postgres operator, this is running. You can see this operator is running operator pod. So now what I will do, I will kill this pod, demo db0. I will kill this and it will be self-healed. So let's do this. Let's kill it and it will be self-healed. So I will open another terminal and run this kubectl get pods so that it continuously monitor. See, it's terminating now. It's terminating, and after some time it will start. It's a bit slow, my machine. Yeah, I can see that it was terminating, and then it was pending, and then container is creating, and it's running 0. And one was like it will start after some time. Container is creating, it will start. So two pods. So one I killed, but it got self-filled and it started running. Okay. So now you can see both the DB0, DB1, both are running. Even after I deleted, it got self-filled. So similarly, I can show other things also. Like for example, we can scale it using this take. We can scale. We can also create. After scaling, we can see three pods are running, and then we can configure the update. We can configure this update, and everything we are able to do with kubectl, right? Kubectl talks to Kubernetes, and using kubectl, we are able to apply this patch on PostgreSQL, right? And it's able to understand this. What is this PostgreSQL? Otherwise, if CRT and operator is not there, it wouldn't have understood what does it mean. Here we are talking about max connection, database related stuff. So there's a database related stuff it wouldn't have understood if you wouldn't have CRT controller, basically operators. And let's run a few more command. Uh, kubectl get CRTs, custom resource definition. kubectl get CRTs, custom resource definition. Here you can see that Zolando PostgreSQL CRT created here. And now here we can also do kubectl get PostgreSQL. This we are able to do because of CRT. We can do kubectl get pods. Kubernetes understand that, but PostgreSQL is able to understand now because of CRT. We are able to see this DemoDB thing. DemoDB is still getting created. Database setup takes time. Container is running, but database setup takes time. kubectl describe PostgreSQL DemoDB. This is also we are able to run passing this PostgreSQL describe PostgreSQL because of CRT. We are able to see all that describes. We can see the logs also. Okay. Let's see the pod name. kubectl okay, pods and then logs Postgres operator. So operator logs also we can see. So to summarize, operator, it's a helper that manages your app inside Kubernetes. CRD is custom resource definition, which teaches Kubernetes a new object type. So Kubernetes will come to know about the new object. Controller, it keeps checking and fixing the app's actual state. And kind is a class that we are using, and kubectl, which talks with the Kubernetes, you already know. So let's go to quiz section. You can also participate. Uh, Try to answer this question. In Kubernetes, what is an operator? Custom resource definition, helper that manages your app inside Kubernetes, controller that teaches Kubernetes new object type. It's a it's an helper that manages your app inside Kubernetes. Answer is B. Operator is combination of CRT plus controller. Then what is the role of custom resource definition in Kubernetes? Monitor set of pods defines new object type in Kubernetes, installs application inside cluster, creates them. Answer is B, because it defines a new object type. Which component watches for changes to resources and takes action to reconcile the state? Operator CRT controller pod. It's a controller. Controller watches and takes action to reconcile the state. What makes an operator different from regular Kubernetes controller? What makes an operator different from a regular Kubernetes operator? Operator only manage namespace. Operators are used CRT to manage application-specific logic. Operator cannot run inside the Kubernetes. Operators are only for monitoring. Answer is B. Operators use CRT to manage application-specific logic. So that's it. Hope you like this video. Please like it, share it, and also follow my Devops Challenge Hub page on LinkedIn. I post quiz daily, and you can participate in the quiz, participate in the contest also, and follow the page. subscribe to the YouTube channel, and also follow WhatsApp channel Devops Challenger. Thank you for watching this video, and see you again on the next video.